Hey there, science fans! Have you ever wondered how a tiny particle can be in two places at once? It sounds crazy, right? This mind-boggling concept is the heart of quantum science. Prepare to have your mind blown as we dive into this fascinating world. Imagine a universe where the rules of our everyday world are turned upside down, where things can exist in multiple states simultaneously. Welcome to the mysterious realm of quantum science. In this incredible journey, we'll explore the fundamental building blocks of the universe, from atoms to subatomic particles. Get ready to uncover the secrets that govern their behavior and challenge everything you thought you knew about reality. Quantum science might seem like something out of a science fiction novel, but it's very real and incredibly impactful. Imagine a world without smartphones, lasers, or even modern medicine. That's right. They all rely on the principles of quantum science. We'll delve into concepts like quantum entanglement, where particles are mysteriously connected over vast distances. It's like they have an invisible telepathic link. Hold on tight as we explore superposition, where particles can exist in multiple states at once. It's like flipping a coin that lands on both heads and tails simultaneously. From the lasers scanning groceries at the supermarket to the life-saving medical imaging technology at hospitals, quantum science is all around us. It's not just theoretical, it's the driving force behind some of the most groundbreaking technologies we rely on every day. So, if you're ready to expand your understanding of the universe and unlock the secrets of the quantum realm, buckle up. This is going to be an exciting ride. Get ready to explore the fascinating world of quantum science and discover how it shapes our understanding of the universe and everything in it. Alright, let's break down this whole quantum science thing. It might sound intimidating, but trust me, it's not as complicated as some people make it seem. In a nutshell, quantum science is the study of the super tiny world, the world of atoms and the particles within them. You see, in our everyday lives, we're used to things behaving in a certain way. What goes up must come down, right? But in the quantum realm, the rules of the game change completely. It's like entering a whole new dimension of reality. Think of it like this. Imagine shrinking yourself down to the size of an atom. Suddenly, the world around you would look and behave in completely unexpected ways. That's the essence of quantum science, exploring the weird and wonderful laws that govern the universe at its most fundamental level. Section 2. Zooming into the microscopic where quantum rules apply. Now, why do we need a whole new set of rules for the quantum world? Well, it turns out that the laws of physics that we're used to, the ones that govern the motion of planets and the workings of machines, they don't quite work when we zoom in to the level of atoms and particles. In the quantum realm, things get fuzzy. Particles can be in multiple places at once, they can be connected over vast distances, and it's impossible to know both their position and momentum with absolute certainty. It's enough to make your head spin. But here's the thing. Even though quantum science deals with the incredibly small, its implications are huge. It's the foundation for understanding everything from the behavior of materials to the nature of reality itself. Section 3. The Quantum Playground, Strange and Counterintuitive. One of the most mind-boggling aspects of quantum science is that it challenges our intuitive understanding of the world. For example, we're used to thinking of things as being either here or there, but in the quantum world, particles can exist in a state of superposition, meaning they're in both states simultaneously. It's like a coin that's both heads and tails at the same time until we observe it. This concept, known as superposition, is one of the many strange and wonderful phenomena that quantum science helps us understand. So as we delve deeper into the world of quantum science, be prepared to leave your preconceived notions at the door. It's a realm where the impossible becomes possible, and where the very fabric of reality is woven from the threads of quantum strangeness. Section 1. Atoms, the building blocks of everything. In the heart of quantum science lies the atom, the fundamental building block of everything we see and interact with. Imagine the tiniest speck of dust you can think of, and then imagine something even smaller. That's the scale we're talking about. Now, atoms themselves are made up of even tinier particles called protons, neutrons, and electrons. It's like a cosmic Russian doll, with layers upon layers of wonder. Protons and neutrons huddle together in the nucleus, the atom's central core, while electrons whiz around them like hyperactive bees. But here's where things get really interesting. These subatomic particles don't behave like the objects we're used to in our macroscopic world. They're governed by the strange and counterintuitive laws of quantum mechanics. Section 2. Diving deeper. The Subatomic Zoo. Let's meet the key players in this subatomic zoo, shall we? First up, we have the protons, carrying a positive electric charge and giving the atom its identity. It's like the atom's name tag, telling us what element it belongs to. Next, we have the neutrons, neutral in charge and providing stability to the nucleus. Think of them as the peacekeepers, keeping those positively charged protons from repelling each other. And last but not least, we have the electrons, tiny particles with a negative charge, constantly buzzing around the nucleus in a cloud of probability. These little guys are responsible for the chemical bonds that hold molecules together and ultimately give rise to the diversity of matter we see around us. Section 3. Quantum weirdness particles acting up. Here's where the quantum weirdness kicks in. Unlike planets orbiting the sun, electrons don't follow fixed paths. Instead, they exist in a haze of probability, meaning we can only predict the likelihood of finding them in a particular region around the nucleus. Imagine trying to pinpoint the exact location of a buzzing fly. It's constantly moving, making it difficult to pin down. That's kind of how electrons behave in the quantum world. And if that wasn't strange enough, these subatomic particles also exhibit wave-particle duality. They can behave like both particles and waves depending on how we observe them. It's like a coin that can be both heads and tails until we look at it. Mind-boggling, right? Section 1. Introducing Quantum Entanglement. Spooky action at a distance. Hold on tight, science enthusiasts, because we're about to dive into one of the most mind-boggling concepts in quantum science: quantum entanglement. Even Albert Einstein himself struggled to wrap his head around this one, calling it spooky action at a distance. Imagine two particles, light years apart, somehow mysteriously connected. When you measure the state of one particle, you instantly know the state of the other, no matter how far apart they are. It's like they have an invisible telepathic link, defying the limitations of space and time. This isn't science fiction, this is quantum entanglement. It's a phenomenon where two particles become intertwined, sharing a fate that transcends their physical separation. It's like they're two sides of the same coin, forever linked, even when separated by vast cosmic distances. Think of it this way. Imagine you have two spinning coins, one in Delhi and the other in London. You flip them both without looking at the results. Now let's say you peek at the coin in Delhi and see that it landed on heads. Instantly, you know that the coin in London must have landed on tails. That's the essence of entanglement. These particles are linked in such a way that their properties are correlated, even when separated by unimaginable distances. It's like they're communicating faster than the speed of light, which, according to Einstein's theories, should be impossible. This bizarre connection isn't just a theoretical curiosity, it's been experimentally verified time and time again. Scientists have successfully entangled photons, electrons, and even larger molecules, demonstrating the reality of this mind-boggling phenomenon. Quantum entanglement has profound implications for our understanding of the universe and its workings. For one, it challenges our classical notions of locality, suggesting that there might be deeper connections between particles than we previously imagined. Moreover, entanglement is paving the way for groundbreaking technological advancements. It's at the heart of quantum computing, quantum cryptography, and even quantum teleportation, where information can be transmitted instantaneously across vast distances. So while the concept of entanglement might seem strange and counterintuitive, it's a testament to the bizarre and wonderful world of quantum science, a world where particles can be linked across the cosmos, communicating in ways that defy our classical understanding of reality. Get ready to enter the mind-boggling realm of superposition, a cornerstone concept in quantum science that'll leave you questioning the very nature of reality. Imagine a quantum particle, like an electron, not being confined to one state but existing in multiple states simultaneously. It's like a juggling act where the quantum world effortlessly keeps multiple possibilities in play. Picture a coin spinning in the air, not yet settled as heads or tails. In our everyday world it eventually has to land on one side. But in the quantum realm, particles and superposition are like that spinning coin, existing in a blurry combination of states until we measure them. It's like they're saying, why choose when you can be both? This isn't just some theoretical mumbo-jumbo. Superposition has been experimentally verified, demonstrating that the quantum world dances to a different tune than our classical intuition. It's like the universe is playing a cosmic game of both and rather than our usual either-or. Section 2. The Uncertainty Principle. Embracing the unknown. Hold on to your hats, folks, as we unravel another mind-bending concept, the uncertainty principle. This principle, formulated by Werner Heisenberg, states that we can't know both the position and momentum of a quantum particle with absolute certainty at the same time. Imagine trying to track down a hyperactive hummingbird. The more precisely you pinpoint its location at any given moment, the less you can know about its speed and direction. It's like trying to catch smoke. The harder you grasp, the more it slips through your fingers. This isn't about the limitations of our measuring devices, it's a fundamental property of the quantum world. The act of measuring one quantity inevitably affects the other, introducing a degree of fuzziness or uncertainty into our observations. It's like the universe is telling us that some things are meant to remain shrouded in mystery. Section 3. Quantum weirdness at its finest, superposition and uncertainty combined. Now let's combine these two mind-boggling concepts, shall we? Imagine a quantum particle in superposition, existing in multiple states at once. The uncertainty principle tells us that we can't know its exact position and momentum simultaneously, adding another layer of fuzziness to the equation. It's like trying to pinpoint the location and speed of a ghost. It's already difficult enough to grasp something intangible, let alone when it can be in multiple places at once. This inherent uncertainty and superposition are not mere quirks of the quantum world, they're fundamental aspects of its very fabric. These concepts highlight the probabilistic nature of the quantum realm, where instead of definite outcomes, we deal with probabilities and possibilities. It's a world where the universe keeps its options open until a measurement is made, forcing the quantum system to collapse into a specific state. Section 4. Navigating the quantum haze, probability takes center stage. In this strange and wonderful world of quantum science, probability becomes our guiding star. We can't predict with absolute certainty where a particle will be or how it will behave. Instead, we calculate the probabilities of different outcomes. It's like rolling a quantum dice, where each face represents a possible state, and the universe decides which face shows up when we make a measurement. This probabilistic nature might seem counterintuitive, but it's the key to understanding how the quantum world operates. It's a world where possibilities reign supreme until a measurement collapses the wave function, forcing the quantum system to choose a definite state. It's like the universe is constantly exploring all possible paths, and our measurements provide a snapshot of one particular path at a given moment. So, as we delve deeper into the quantum realm, let's embrace the uncertainty, marvel at the superposition, and accept the probabilistic nature of this fascinating domain. It's a world where the universe reveals its secrets in whispers of probability, challenging our classical intuitions and opening up new avenues for exploration and discovery. Hold on to your hats, science enthusiasts, because we're about to dive into the real-world applications of quantum science, where the bizarre and wonderful transform into groundbreaking technologies that are shaping our present and future. From the lasers that scan our groceries to the mind-boggling potential of quantum computers, the impact of quantum science is all around us. Let's start with lasers, those ubiquitous beams of light that have revolutionized everything from telecommunications to entertainment. Did you know that lasers rely on the quantum phenomenon of stimulated emission? It's like coaxing atoms to release photons in unison, creating a highly focused beam of light with remarkable properties. And then there's quantum computing, the holy grail of computation, promising to revolutionize fields like medicine, material science, and artificial intelligence. While still in its early stages, quantum computers leverage the principles of superposition and entanglement to perform calculations that would take classical computers billions of years to solve. It's like having a computer that can explore countless possibilities simultaneously, unlocking solutions to some of humanity's most daunting challenges. In our increasingly interconnected world, data security is paramount, and this is where quantum science steps in with another groundbreaking application: quantum cryptography. Imagine a world where communication is inherently secure, immune to eavesdropping and hacking. That's the promise of quantum cryptography, which leverages the principles of quantum mechanics to create unbreakable encryption keys. Remember quantum entanglement, that spooky action at a distance? Well, it turns out that this bizarre phenomenon can be harnessed to create secret keys that are impossible to intercept without disturbing the entangled particles, alerting the sender and receiver to any eavesdropping attempts. It's like having a communication channel protected by the very laws of physics. Quantum cryptography has the potential to revolutionize secure communication, safeguarding sensitive data from hackers and cyber attacks. It's a glimpse into a future where privacy and security are no longer an afterthought but an inherent feature of our digital interactions. Here's a fascinating twist. Quantum science isn't just confined to the realm of physics and technology, it's also making waves in the field of biology, where scientists are uncovering the hidden quantum secrets of living organisms. From the way birds navigate using Earth's magnetic field to the efficiency of photosynthesis, it seems that nature has been harnessing the power of quantum mechanics all along. Take, for instance, the sense of smell. Researchers believe that our ability to distinguish a vast array of scents might be linked to quantum tunneling, a phenomenon where particles can pass through energy barriers that would classically be impossible to overcome. It's like our noses are equipped with tiny quantum sensors detecting subtle differences in molecular vibrations. And then there's photosynthesis, the process by which plants convert sunlight into chemical energy. It turns out that this vital process relies on quantum coherence, where energy is transferred with remarkable efficiency thanks to the wave-like nature of light and the precise arrangement of molecules within chloroplasts. It's like plants have mastered the art of quantum energy harvesting. These discoveries are just the tip of the iceberg, hinting at a deeper connection between the quantum world and the intricate workings of life itself. Quantum biology is a rapidly evolving field, promising to unravel some of the most profound mysteries of life on Earth. As we conclude our exploration into the fascinating realm of quantum science, it's mind-boggling to realize how much we've uncovered. We started with the fundamental building blocks of matter atoms and their quirky subatomic particles, and delved into the perplexing concepts of superposition, entanglement, and the uncertainty principle. Quite a journey, right? We've seen how these mind-bending concepts, far from being confined to theoretical physics, have real-world implications, shaping the technologies we rely on, and even offering glimpses into the hidden workings of life itself. From lasers and quantum computers to unbreakable encryption and the mysteries of photosynthesis, quantum science is leaving its mark on our world in profound ways. But perhaps the most significant takeaway from our journey is the realization that we've only just scratched the surface of this enigmatic realm. Quantum science is a field teeming with unanswered questions, uncharted territories, and the potential for groundbreaking discoveries that could revolutionize our understanding of the universe and our place within it. So, what's next on this quantum adventure? Well, the possibilities are as limitless as the quantum world itself. Scientists are constantly pushing the boundaries of knowledge, exploring new avenues in quantum computing, delving deeper into the mysteries of quantum biology, and searching for ways to harness the power of entanglement for even more mind-boggling technologies. But you don't have to be a physicist to appreciate the wonders of quantum science. Keep asking questions, keep exploring, and keep your mind open to the possibilities, no matter how strange or counterintuitive they may seem. Who knows what other secrets the quantum realm holds, waiting to be uncovered? If you enjoyed this deep dive into the world of quantum science, don't forget to hit that like button and subscribe to our channel for more mind-expanding content. And be sure to share your thoughts and questions in the comments below. We'd love to hear from you. Until next time, keep those quantum minds buzzing. Alright, science fans, let's address some of those burning questions that might be swirling in your minds after our deep dive into the quantum realm. First up, a big one. Is quantum science real? It might sound like something out of a science fiction novel, but trust me, it's as real as the device you're watching this on. Quantum science has been rigorously tested and verified through countless experiments over the past century. It's not just theoretical, it's the foundation for many technologies we use every day, from lasers and transistors to medical imaging devices. So, yes, the quantum world is very much a reality, even if it seems strange and counterintuitive at times. Another common question: is quantum science only for physicists? Absolutely not. While the math can get complex, the fundamental concepts are accessible to anyone with a curious mind. Plus, understanding the basics of quantum science can enrich your understanding of the universe and everything around us, from the smallest atom to the vast expanse of space. Now you might be wondering, how does quantum science affect my life? The answer might surprise you. As we've explored, quantum science is the backbone of many technologies that shape our modern world. Those smartphones we're glued to, they rely on transistors, which are based on the quantum properties of semiconductors. The lasers scanning groceries at the supermarket, they wouldn't exist without our understanding of quantum mechanics. Even the internet and the computers we use every day owe their existence to the principles of quantum science. Beyond these everyday technologies, quantum science is driving innovation in fields like medicine, materials science, and energy production. From developing new drugs and therapies to creating more efficient solar cells and exploring the potential of quantum computing, the applications of quantum science are vast and rapidly expanding. For those of you eager to delve even deeper into the quantum rabbit hole, there's a wealth of resources available online and in libraries. Books by renowned science communicators like Brian Greene, Michio Kaku, and Carlo Rovelli offer engaging and accessible explanations of complex quantum concepts. Online platforms like YouTube channels dedicated to science education such as Veritasium, Kurzgesagt, in a nutshell, and PBS Spacetime provide visually stunning and thought-provoking explorations of the quantum world. And if you're feeling adventurous, you can even find online courses and lectures by leading universities that offer a more in-depth dive into the mathematics and theories behind quantum science. Remember, learning about the quantum world is an ongoing journey of discovery, and there's always something new and fascinating to explore.